Hello Graylog Go. My name is Paul Duto and I work as Head of Cyber Defence for a Nano National CSIRT, a cybersecurity emergency response team. And this is my talk about how we use Graylog within our National CSIRT. Prior to being the Head of Cyber Defence, I was a CTO at a cyber company specialising in penetration testing, incident response, SIEM and digital forensics, and have been a Graylog user since somewhere around about 2016-2017. I have used both Graylog Go and Graylog Enterprise. So, let's get started. What will we talk about? We'll talk about what is a Nano cybersecurity emergency response team. We'll talk about why Jersey has one, our cyber shield, the vulnerability assessment service, which is part of our cyber shield, how the JCSA uses Graylog and does some of its monitoring. We shall talk about our incident response VM based on Graylog, developed to solve problems for ourselves. I shall introduce the concept of a Graylog management server. I will show you how you can get some free CTI and rules to prevent most attacks, including ransomware, and I'll share a couple of general tips and tricks. So, without much ado, let's get started. What is a Nano National CSIRT? Well, CSIRT is a cybersecurity incident response team, and you have a national responsibility for a constituency. So you can think of things like the National Cybersecurity Centre in the UK, but on a much smaller scale. The term was coined by myself at a First.org conference recently, and generally your constituency should be less than 750,000 people, and generally Nano National CSIRTs have challenges due to scale, both in people and technology. Solutions that you could use for bigger national CSIRTs don't scale down, and then you're trying to do more things with more people in a small national CSIRT. And as you can see, this is our constituency on the left here. It's made up of a number of ASNs from our telcos and various other people, and our mantra is to prepare, protect and defend the island of Jersey against cybersecurity threats, whether that is for a person, for a business, for a domain, etc. Other examples of Nano National CSIRTs are CERT BS, the Bahamian CERT, Trinidad and Tobago CERT TT, and Monaco CERT MC. So why does Jersey have one? Well, it's an independent jurisdiction, technically known as a Crown dependency, with our own parliament, government, critical infrastructure such as banks, regulators and telecoms. We also happen to be a top global international finance centre, recently passing MoneyVal and other regulations. We have around about £360 billion in regulated funds. We have around 35,000 companies registered, an international airport connecting to 10 plus UK airports, and we have a cybersecurity community here of 300 plus people in something called the Channel Islands Information Security Forum. This was started around 2013 by some people in the island to advance cybersecurity. We also have some great beaches, restaurants and hotels, and are the warmest place in the British Isles. So what is Jersey's Cyber Shield? It's a concept. So the idea is that you have the bad guys on the left trying to attack the island, and we have our cyber shield, and within that cyber shield there are a number of services. So you can see our advanced warning service. This is really customized honeypots waiting for attackers to attack them to give us information. We have our vulnerability assessment service, which we shall talk about shortly. We have active scanning, which is actually going out and physically scanning around about 70 to 80,000 IP addresses. And then we have coordinated vulnerability disclosure. So that's when somebody comes to us and says, hey, I found a problem with this system, can you go and talk to the owner for me? And then there's us there in the middle, doing our thing, providing analysis and response, and then on the right, outputs. So we have like local cybersecurity insights, public advisories, and targeted information sharing. Now, not all services are in service due to the delayed cyber law, and Graylog is used to support some of the services in the Cyber Shield. So, let's talk about how our vulnerability assessment service works. So we have third-party passive vulnerability data for our constituency. It comes in every day from our provider, and we process that, and we use Graylog as part of that processing pipeline. And we used it at the start, nearly 2 years ago, to create an initial dashboard to display data, to aid our own understanding and to raise public awareness. And the particular dashboard you see there in front of you is actually on display in our building. Our building is public and people can come in, and we use it to mine data and contact constituents. So each day we will check for new systems that have been put online that are publicly internet facing, and if they have a security issue or vulnerability or potential security issue, we will try and find the owner of the system and contact them and say, hey, you've put this on the internet here, we perhaps don't think it's a good idea, would you like to do something about it? And we get varying responses, but the idea is to try and prevent compromises or attacks before they happen. So what do we use Graylog for? So one use case we use it for is log visibility. We have a number of cloud providers, we have some AV EDR logs, we have Linux systems to provide services, we have a few Windows systems, and we use it in incident response. We also have a managed service provider. So we have a particular area where we have sensitive information, and we need to maintain that access is only by JCSE staff, and we also need to have visibility in work undertaken on our laptops. Now we have two types of laptops. We have a very hardened general day-to-day use laptop, and we have forensic laptops. And it's the day-to-day laptops that we need the visibility on. We use it for incident response. We use it for any attribution of any internal security issues. We use it as part of our incident response VM. We use it for training in our JCSE Cyber Lab, and this is a vulnerable Active Directory on-prem infrastructure, which is used to teach cybersecurity to members of the team and IT suppliers. So let's go and have a look at some dashboards then. So here you can see actually a live vulnerability assessment dashboard. We have a number of open systems here. This is the number of vulnerable systems, and then they are split by type. So for example, this is, and we can see trend information. So we can see this is ICS systems, this is FTP servers, this is rsync servers, and so we track this daily and we use it to go and try and be part of our vulnerability service. Then the next dashboard I'm going to show you is actually from our laptop monitoring. So we monitor our laptops using various technologies, including Sysmon. And you can see we have some quite good feature sets. We have quite detailed information on what's actually going on our laptops, where the connections are, where they're going, and the sort of endpoint summary. So how do we do this monitoring? Well, we use GPOs applied according to the Australian Cybersecurity Technical Guidance. Now in there is very good guidance for how to set up GPOs to set your Windows systems so that they log correctly. By default, Windows systems do not log very much. A workstation, maybe a day, a server, half a day, which makes instant response pretty much, well, impossible without the bad guys actually trying to destroy the logs as well. but we don't take event ID 4688, process creation and termination. And the reason why we don't set that up is because there's no way to filter it when you set it up by GPOs. This means that your SIEM ends up being full of rubbish events which consume your storage, your bandwidth, your ability to search, and many other things. So what we do is we use a sysmon configuration to do that particular process creation, registry keys, all of those sort of things. We also do some targeted event filtering. This reduces network bandwidth and ensures that our SIEM only has meaningful events. Now, you're going to ask me, how do you decide what events or what event IDs to take? Well, there's a number of ways you can do this, but originally the way I started was taking some very famous papers such as tracking the anniversary from the NSA, some ones from European conferences, and looking at the stages of attack and then taking each stage and the event IDs you need. And that is the sort of basis for our logging, and we also use that as well for our Graylog IR as well. And as I said, we have a custom sysmon, and our custom sysmon has basic attribution of MITRE attack references at source. So basically they come as a field and we key value separate them, and then we have MITRE attack references from each endpoint. This gives us less SIEM load, and we can also then filter out on the type of events possible, and we can also give them risk scores. So this means that we also have client log enrichment at source. So for Linux systems, we take syslog, and then we use audit-d with a configuration, and then we use a tool called Laurel. And the reason we use Laurel is that if you look at the logs from audit-d, they are really unfriendly, as you can see there, and just in the before. That's virtually unreadable by a human. However, with Laurel, it transforms it into a nice JSON-L format that you can see below the arrow. This is then very readable. As you can see, that's a Perl reverse shell. And then we use Filebeat to ship the Laurel logs to Graylog. So basically, Laurel is an audit-d plugin, and it creates its own log file, and we just use Filebeat to ship that in, and then we use ship syslog in. So a while back we had a significant high-profile incident where I had 90 gig of IIS logs over a period of 3 years. I basically had to add nearly 100 directories with thousands of files in, and I needed a way to analyze them. Most traditional methods didn't work. You could analyze in part. We tried things like log parser studio, we tried a few other things, but I eventually settled on having ingesting the IIS logs with a custom Python script into a Graylog instance. And if you've had to deal with IIS logs, they're reasonably notorious in that the first 5 lines of the log all have a hash, and then you have the data. But if you look at line 5 there, depending on how your IIS is set up on your Windows server, those fields change. So we ingested the 90 gig of logs, and then we started looking for patterns, and what you can see is one of the patterns of attack there. So how does it work? Well, it supports Windows EVTX log ingestion via PowerShell script, and we'll talk more about that in a second. It supports IIS logs, and I mean a certain version of IIS, JSON logs, CSVs. Events are automatically filtered. The filtering is customizable. The logs are enriched, and then we will have customizable detection rules and pipelines. So this is more of a deeper dive of the architecture. You can see for the Windows logs, they're ingested via a PowerShell script to a Beats input, and then separated by stream filters into streams, and then pipelines, and then indexes. This is reasonably standard best practice to avoid things like the 1,000 fields, which you'll quite happily get with PowerShell logs if you lump them in with Windows Server and Workstation logs. So, we ingest the logs and then we filter them, and this is the filtering rule. It just is a drop rule based on event ID. And then we set the timestamps, and we set a couple of fields to make things appear on the timeline. And we can customize these. And for example, for a list of Windows event filtering that we do, you can see for each log source the events we are going to take and what we're using them for. So what does this look like in reality? Well, this is actually our incident response VM with some data from an incident. It's from a real life ransomware incident. So we can see just on the front page the number of logs per log source. So this is WMI logs, Windows system logs, task schedule, terminal services, security application, defender, and WinRM. But as you can see, just looking at that, the first place you might want to start is scheduled tasks, because there seems to be a lot of scheduled tasks created. And here you can see various points where there were 200-300 scheduled tasks created in the environment, tasks over time, things of that nature. We can also see there was quite a bit of terminal services action where the attackers laterally moved through the environment. I can't show you too much more because it is real life incident data, but the project will be updated and soon we'll have detection rules and pipelines, and if people would like to participate and contribute rules, they're more than welcome to. So, let's talk about another one of my concepts, the Graylog management server. This I used to use with Graylog Open, and the reason I used it was to solve a number of problems. One was how to back up indexes, so my solution for that was using a tool called Elastic Dump, and your management server has a big, slow, local attached disk, and we wrote a bash script, and it would use Elastic Dump to pull the indexes down and stored them as compressed JSON, and we stored them in a day, month, year calendar structure. It's quite good. I mean, you get about an 18 to 21 compression ratio on JSON, and this was used with a clustered Graylog Open that was doing around 220 gig of logs a day, and the particular bash script backing up all the indexes would run over about 3 hours overnight. We also used the management server to retrieve external logs, so you can think of things like O365 using FileBeat module. We also had a miniature all-in-one on the management server, and there's a good reason for this. Our clustered system was running reasonably hot, shall we say. It was doing around 220 gig of logs a day ingesting, and people were obviously doing searches. So you would load the system up, and when you were doing a restore, and other things would grind to a halt. So what we did was take the logs that we had stored in compressed JSON and just refire them back into an input. They go in super quickly. You can do your instant response because your logs are all processed, and you don't affect your main system. We also used it for monitoring our Graylog health. So we created an API key. We use Python with Elastic Zabbix and Zabbix. So you have Zabbix for monitoring your health of your clusters, you know, your operating system disks and all of that sort of thing, service restarts. We use Elastic Zabbix to talk one node in an Elastic Search or Open Search now cluster to get that data, and then because Zabbix ran the Python scripts, it had the data, and then we installed Grafana, and we have beautiful dashboards. Our management server could also act as a threat intel source, so it could download threat intel data and have Graylog query it or send it into Graylog. We also had a status input, so that any scripts could be run, could be confirmed as working. So they would run, they would send something into the status, they would tell us each time an index is backed up, how they are finished, and so therefore we could create alerts. So if we didn't see a field with certain things finished, it would fire off an alert, we'd know backups or something else had gone wrong for a customer, and it would come into our ticketing system, and we'd just go and fix it. So, this is how to get some free CTI and rules. So, if you're not familiar with Census is like Shodan, and it's a search engine for the internet, but it's based on banners and headers rather than keywords. So, there's a label in Census called Open Directory. And what that means, it's where there's an open directory on the internet, and often attackers will store their tools in there. And this can be anything from malicious exes, Cobalt Strike beacons, copies of Cobalt Strike, all sorts of things. So what you do is you use your free Census allocation, and you make that query you see on the screen, and it gives you a list of open directories. Now you can manually sort through that, but my favourite method is to take that and then use either one of the two versions of Eyewitness to take screenshots. So you'll see down there in the GitHub links there's a Reg Siege and a SensePost version. So you feed it a bunch of IP addresses, it goes and takes screenshots, and then you review the screenshots. And if you find an open directory, as people do, there's a very good link there from the DFIR report, showcasing the technique. So you basically go to the attacker's open directory, and you use I use a sacrificial Linux box for doing this, and you take the files and you inert them, and then you use them to create rules. So you can see on the left here, this is a common attack where attackers will delete or change registry keys for persistence, disabling software, disabling Defender. So we can write rules on the right, and that's a sysmon rule to detect that. So if you have sysmon with registry keys being watched, you can detect when the ransomware crews try to disable your antivirus or do other things. You can also look for things such as shadow volume copies being stopped on a host, classic indicators of persistence via registry. There's a number of ways you can do that, but you basically get what the attackers want to turn off to make sure they can do what they want to do. So all you have to do is write rules to alert for what the attackers want to turn off. And that might sound a little flippant, but there is a lot of commonality of the techniques between ransomware crews, for example. So having even just detections for some things that might be used by one crew but not another, there's an overlay. For example, if you look at the Conti ransomware manual, the AD find tool is used a lot. Less so now, but it was a while ago. So next, tips and tricks. Managing your sysmon configurations. There's a tool there called Sysmon Config Pusher, which allows you to manage your sysmon configurations, and you can push some different sysmon configurations out to different endpoints, and you basically put tags in your sysmon files. Why you would do this is that it's quite common because certain types of sysmon events are very voluminous. So think process accessed, event ID 10 is quite bad, and unless you really tie it down, you're going to get a lot of extraneous data. So you may not want to put that, for example, on servers, but you might want to put it on certain high-value workstations, as an example. So you can push different sysmon configs out to different places. And what it does, it takes the current sysmon binary that's on sysinternals, and pulls it down. Now, if you want to not use that one, but just use, your own a particular specific version, you can just modify the line in Visual Studio Code or Community and point it to a share or an S3 bucket, and it will pull it from there. If you're going to invest in ETW, then this is probably the current best tool out there. The previous tool that I've used, called Silky TW, is no longer maintained by Mannion, but it still works. But this can help you gain visibility and ingest your ETW logs. Lastly, one of my favourite ones is, once you've ingested all your logs, you've parsed them all, you've actually got 2 copies of your logs, as in the full message that was in your logs, plus all the fields split out from the full message. So in my mind, you don't need the full message anymore. You can set it to parsed, and that will save you around 25% space saving on indexes. Another trick that I know some people do is they have a pipeline rule that concatenates a few fields and then sets that to a variable and sets that to parsed. Lastly, there's a few very good Visual Studio Code utilities to help us. There's a Sysmon syntax checker by Carlos Perez, aka Dark Operator. And when you have Sysmon config files, like some of the ones that I use that are several thousand lines long, it can be very hard to debug XML, and this makes it super easy. And then the last 2 plugins I recommend is one for writing Graylog rules inside VS Code. It does syntax checking. And then there's another one by Graylog Labs, which is a rules manager, which I haven't used. I came across the other day, but it allows you to upload rules to a Graylog instance, assign them to pipelines, all from Visual Studio Code. So maybe worth checking out. Could be also possibly useful as part of a detection and code pipeline, but I'll leave that for you guys and girls to all go and look at. Anyway, thank you very much. My name's Paul Duto. If you have any questions, feel free to ask.